Now let us learn something about pattern. So let us study this way. First let us see the functions of the pattern. Next we will see the pattern material. Next we will see the ideal characteristics of a pattern material. Next we will see pattern allowances. Next the types of pattern, and finally we will see the core and core prints. The pattern. So the pattern is the replica of the object to be cast. So as I have already told, it acts as the model to create the mold cavity. So whenever we want to cast a particular component, we have to create a cavity whose shape is similar to that of the component to be cast. So the model or the pattern which we are going to use should be similar to that of the casting that we are going to make. However, the geometry of the pattern will not be exactly same as that of the geometry of the casting. It will be modified in certain ways. And what are these modifications? One is there will be some pattern allowances. So because of these pattern allowances, the geometry and or the size of the pattern will be little different than that of the geometry of the casting. And another modification is we have to place the cores. So cores are to be supported. For supporting the cores, there should be some place. So this place where the cores are to be supported should be created by the pattern. So when we design the pattern should be in a position to prepare a place where the cores will be placed. So in that context, even the pattern geometry will be modified so that it can accommodate cores. So there will be two modifications for the pattern. First modification is because of the allowances. These allowances we will be seeing later, and second modification is in the context of core prints. And what are the functions of the pattern? First function is it prepares the mold cavity. Whatever component or whatever shape we are going to make, we use the pattern of a similar shape, and when we keep the pattern inside the molding boxes and we ram the molding sand, we compact the molding sand. After compaction is over, we remove the pattern and there will be a cavity whose shape is similar to that of the casting that we are going to make. So it prepares the mold cavity. And second function is it enables creation of core prints. Yes, whenever we make a casting in which there is a hole, for that purpose we have to use a core, sand core. Some cases these sand cores are supported by choplets. Some cases these cores are supported on the ends. Sometimes the cores are supported on the ends and as well as with the help of the choplets. So when the cores are supported on the ends, it has to rest at say some place in the mold. That place has to be created. That place has to be created by the pattern itself. So the pattern will create the core print. This core print makes a place for resting of the cores. And also in a mold, not only there will be a cavity of the component that we are going to make, but there will be a cavity for sprue, there will be a cavity for runner, there will be a cavity for ingates, there will be a cavity for riser, and the pattern has to create hollow cavity for all these elements. For runner, it has to create a hollow cavity. For sprue, it has to create a hollow cavity. For gates, it has to create a hollow cavity, and for riser, it has to create a hollow cavity. So a pattern has to create a hollow cavity for the component itself, for the sprue, for the runner, for gates, and for the riser. And patterns properly made and having smooth surface will reduce casting defects. So a good pattern should be in a position to reduce the casting defects by smooth surface, and properly constructed pattern minimizes the overall cost of the casting. And what about the pattern material? Most of the times the pattern material is wood. In some cases it is metal. Sometimes it is made up of alloy, and plaster of Paris is also used, where we achieve good dimensional accuracy and also good surface finish. We use plastic and rubber. We also use wax, where we get excellent surface finish, and also we use resins. So these are all the pattern materials. Each material has got some advantages and limitations. For example, if we take the wood, wood is cheaply available, but when we make a mold with a wooden pattern, the inner surface of the mold cavity, it will be poor. The casting finally that we are going to obtain will suffer from poor surface finish. That is one thing. And another thing is, we mold the medium with molding sand in which there is moisture. This moisture, when comes in contact with the wooden pattern bulges, its geometry becomes larger. So this is one of the drawback of the wooden pattern. And when we use metals, the surface finish is good, but there is a chance they may undergo corrosion. So this is the drawback of the metal patterns, and also metal patterns are expensive. Metallic patterns and alloy patterns are expensive. And coming to the plaster of Paris, and it offers very good surface finish, and also it offers good dimensional accuracy, but it is expensive. And also preparation of the mold, it takes time, takes more time. And also we can use plastics and rubbers, and they offer us good surface finish. And we also use wax in investment casting, where the surface finish is excellent, the dimensional accuracy is excellent, especially when we have to make castings of very thin cross section. We can go for wax pattern. Another drawback of the wooden patterns is, if we have to make castings of very thin cross section, wooden patterns will not help us. But if we use the wax pattern, even a thin cross section of the order 0.75 mm, we can successfully cast. But this wax, each time when we prepare a pattern, that is only for one casting. On the other hand, if we make a pattern with wood or with a metal or with alloy, they can serve as patterns for making several molds. But whereas when we make a pattern with wax, it is only for one time. After we cast one casting, we have that pattern is no more, it will be melting. And we can also use resins, but these resins are expensive. And what are the ideal characteristics of a pattern material? One is, they should be easily worked. To give the shape, we should not find it so difficult to give the shape. We should be in a position to give the required shape easily. And second characteristics is, it should be light in weight, and third, it should be strong, hard and durable. When we make a pattern, it has to serve as the pattern for several castings. So that is the objective. So when we make pattern, especially with wood and metal or alloys, they serve as pattern for making several molds, and it should be resistant to wear and abrasion. So this is very important. When we place the pattern inside a molding box, we start ramming the molding sand, and we compact the molding sand with rammers. It is that time the pattern is subjected to wear and abrasion. And if the pattern material does not have resistance against wear and abrasion, within no time it will lose its geometry. It can't serve as a model for making several molds, whereas a ideal pattern material should have good resistance against wear and abrasion, and the pattern material should have good resistance against corrosion. This comes when we use metals and alloys as the pattern material. The compacting medium, that is the molding sand, contains moisture. When we place the pattern inside the molding box and when we start ramming the molding sand which contains the moisture, it is that time the pattern should have resistance against corrosion. If the pattern material does not have resistance against corrosion, it will be rusting, and within a short time it will be losing its geometry, and it should be resistant against chemical reactions also. And next one, it should be dimensionally stable and unaffected by the variations in temperature and humidity. Yes, when we make a pattern, it should be dimensionally stable, and especially when we use metallic patterns or alloy patterns, there is a chance that they may expand if the temperature in the shop floor is high. If the pattern expands, even the casting will be of a bigger size, that is not going to serve the purpose. And if the humidity is more, and if the pattern absorbs humidity, again it will be bulging and it will be enlarging. Finally the casting that we are going to make will be of a bigger size. This is not going to be of any use. So when we make a pattern, the pattern should be stable and it should have resistance against thermal fluctuations and humidity, and finally it should be available at a lower cost. If the pattern is of higher cost, it will increase the overall cost of the casting. So the pattern material should be available at a low cost.